All right, here I am on page 8, and this is assignment number 5, and we're going to talk about two exponent properties, two rules about exponents involving parentheses. Okay, so our first rule is called power to a power. Okay, this is the first rule. So here's what it is. Okay, it is, let's say I have something like this, a to the third, right? And that whole thing is taken to the fourth power. So let's really think about, what does this mean? A to the third to the fourth power. What does that actually mean? And we can use what we already know, right? This is not really new information necessarily, because look, what does this mean if something is taken to the fourth power? It means that I have this, whatever is in here, multiplied by itself 4 times. Right? That means this. Okay, so what happens here? Well, we know this is what we just learned. We add these, so this is a to the 3 plus 3 plus 3 plus 3 power. Okay, well, what's 3 plus 3 plus 3 plus 3? That's the same as 3 times 4, right? Adding 3 to itself 4 times. That's the same as 3 times 4. Okay, and 3 times 4 is 12. Okay, so what we want to do is not do this, right? Not do this. We want to say, oh, when I have a situation like this, here's the shortcut, right? It just becomes a to the 3 times 4. It becomes a to the 12. Okay, let's do one more. Let's say I have, so here's one example. Let's say I have another example. X squared, and it's now to the 5th power, right? What does that mean? That means x squared. And what I could do is I could even do this, right? I could say, okay, well, that's x squared. Here's x squared times x squared times x squared times x squared times x squared, right? Now, the hope is that you're not ever going to write this out, right? That we're going to kind of notice the shortcuts, observe the patterns, and use the patterns. Well, what does this equal? This is 2 plus 2 plus 2 plus 2 plus 2. Right? This is going to be, and again, right? This is the super long way. This is just going to be 2 times 5. Okay? You can count, these are 10x's. Okay, but what we want is when you see a problem like this, you say, oh yeah, I remember how this works, right? You can kind of picture this in your head and say, oh, what is that? Oh, that's just going to be 2 times 5, so that's just going to be 10. Okay, so that rule is called power to a power. Why? Because there's a power right here, and it's to an exponent, right? Sometimes we use to a power as meaning to a particular exponent. And so the rule is written like this. The rule is written like this. Let's say I have x to the a to the b power. I multiply those together. This becomes x to the a times b, okay? So if you ever have something that looks like this is how the rule is written, okay? Now, there's another rule, and this is where things start to get really interesting. Power of a product, okay? So let's just think, right, power, we're going to work with exponents, of a product. Product is things being multiplied together. So for example, here's a product, 3x. And if I take that to a power, if I take that to an exponent, like this, what does that mean? That means this, 3x times 3x times 3x times 3x. Okay, now we know with multiplication, order doesn't matter, right? 3 times 5 and 5 times 3 are the same. So I can mix up the order of these. So for example, I can rewrite this as 3 times 3 times 3 times 3 times x times x times x times x. And so we observe that this is actually the same as, right? This is 3 to the 4th times x to the 4th. And so we notice oh, if I have 2 things in here, right, and there's a power on the outside, this just power just kind of gets attached to each of these, right? This becomes 3 to the 4th times x to the 4th. Okay, and just a quick note, like 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 is 81. So like this would actually be, we would write it like this. Okay. Let's do another one. Let's say I had something, and it sort of doesn't matter how long and complicated it gets, because let's say that you're feeling a little confused or mixed up. You always have the option of really just writing it out the long way, right? The idea is that we're going to notice some shortcuts here that will empower you not to write it out the long way, but you can always just do it, right? Like this. This means 2 times x times y, right? This is y squared, so this is 2 times x times y. And if it's to the 3rd power, that's 3 times. Okay, well, let's see. 2 times 2 times 2, right? We can write that out separate. There's 1, 2, 3 x's. And there's 1, 2, 3, 4, 5, 6 y's. And again, right, order doesn't matter, so I can write it like this. Now, what does this become? 2 times 2 times 2, that's 2 to the 3rd, right? X times x times x, that becomes x to the 3rd, and then y times itself 6 times. This is y to the 6th. And then, of course, if I have a number like this, this is just a number. This is 2 times 2 times 2. I can figure that out. 2 times 2 is 4, times 2 is 8. This becomes. Okay, now let's take a look and see if we can figure out a shortcut here. So if I go back to the beginning, look, look at the beginning, I'm going to look at my answer. So this became 2 to the 3rd, which is 8. There it is. This became x to the 3rd. There it is. And this became y to the 2nd to the 3rd. And look, there it is, because we know if we just had, for example, just like this, right, y to the 2nd to the 3rd, what does that become? Well, that just becomes, right, this is just multiplication. This is what we just talked about up here. So we know that something like this would become this. Okay, so notice, again, you can always write it out the long way, but just observe that you can also just kind of apply this exponent to each thing on the inside. That's like the sort of the shortcut, right? Okay, let's look at another situation really quick that might come up. Look at this. Negative 5x to the 3rd, I'm just going to do it like this. What happens here? Okay, so we're going to write negative 5x times negative 5x times negative 5x. Okay, I'm going to be mindful of the signs here, because this becomes negative 5 times negative 5 times negative 5 times x times x times x. Okay, so this becomes negative 5 to the 3rd. Now look, watch what I'm going to do. Times x to the 3rd. Now these parentheses are important, because if I write like this, this is actually, this could be 5 to the 3rd, and then whatever you get, make that negative, right? Whereas this is actually negative 5 times negative 5 times negative 5. Whereas this could be like negative 5 times 5 times 5. So that's just a little bit different, okay? And you're going to see it matters in certain cases. So let's just do this math, right? Negative 5 times negative 5, that's positive 25. Negative times negative is positive. 5 times 5 is 25. So 25 times negative 5, that's a positive times a negative. That's negative. 25 times 5 is 125. Okay, now notice this answer came out negative. Okay, what I want you to be mindful of is, like, let's do 2, for example. Negative 2 to the 1st power, is negative 2, because anything to the 1st power is just itself. Now, what's negative 2 to the 2nd power? Well, negative 2 times negative 2 is 4, positive 4. Okay, because negative times negative is positive. Now, what about negative 2 to the 3rd power? Well, that's negative 2 times negative 2, which is 4, times another negative 2. Well, that's positive times negative, that's negative 8. What if I take it to the 4th power? Okay, so I'm multiplying another negative 2. That's negative 8 times negative 2, that's positive 16. So if you see what's happening with the signs here, right? If I have an odd power, the answer is going to end up being negative. But if I have an even power, I'm going to end up multiplying negative times negative and get positive. Okay, so just be mindful of that. Let's just do one last, like, big problem so you can just see it, that no matter how big the problem gets, the rules just stay the same. So I'm going to purposely make this like super long and obnoxious, right? And you're going to see that it is long and obnoxious, but it's not super difficult. It's just super annoying. Okay, so here I'm multiplying a bunch of stuff together. Okay, so what does this mean? Well, this means I'm going to multiply this 4 times a squared times b cubed, right? Now this is squared. So you have a couple options here. You could treat this piece like this and kind of do out the math first. Or you could say, okay, well, this is square. This is multiplied by itself twice, and you could just write it twice. Okay, and then we get to the deal of order not mattering, right? So this is 4 times, right? So I'm multiplying just all this junk together. So I'm going to grab the numbers first. Okay, and now I'm going to grab all my A's, right? So here's, look, I'm going to get my A's next, right? So here's my 2 A's, another A here, another A here, and 2 more A's here. Okay, I'm going to grab my B's next. So here there's 3 B's, another 2 B's, another 2 B's, and there's no B's here. Okay, so 4 times 3 is 12, times 3 is 36, times 2 is 72. And how many A's? 1, 2, 3, 4, 5, 6. How many B's? 1, 2, 3, 4, 5, 6, 7. Okay, so that's the answer. Now, I did it kind of the long way, but you can do it in less time because look, I could just looked at this and said, okay, 4 times 3 times 3 times 2. Okay, there's 2 A's plus another A, that's 3, plus another A, that's 4, plus another A, there's another 2 A's, that's 6, right? Like I didn't really have to write this out, but you can always choose to if it helps you. Okay, so here, what we've discovered, our final rule for this video is that if you have, let's say, 2 things inside being multiplied, and there's an exponent on the outside, that exponent will apply to each piece on the inside.